everyone. Welcome to Ask IITians. So, students, do you remember that in the last session what we were discussing? So, exactly, we have discussed about the acids. That what are the acids, what are the types of the acids, and what are the properties of acids. Exactly, we have discussed all such thing in the last session. So in today's session, student, we are just continuing with the same chapter because we have to cover up bases and the salts as well. So in this session, we are going to see that what are the bases and what are the properties of the bases as well. And students, in this session, you will be finding something very interesting. Interesting in what way? That you'll see that how the indicators are changing their color in the presence of the acid and bases. So that's how we'll see different type of indicators as well. So I hope this session is going to be interesting for you. So just start with this session. Okay, so these are the topic, students, which we are going to cover in today's class. So it's yes, first of all, we are going to discuss about the bases because we have discussed about this acid in the last session. So now we are going to discuss about the base. Then we are going to see what are the properties of the base. Then it is the natural and synthetic indicators. Then these are the indicators, students. Okay, now these are the indicators, and we'll see that how the indicators are changing their color in the presence of the acid and base. So we'll see all such thing in session. Fine. Okay, so first of all, students, starting with the bases, that what are the bases? If I ask you what is the acid, so you'll say, ma'am, yes, I have watched the video, so I know this thing, what is the acid. So what is the acid, student? So we have seen this thing that the acid is something, or acid is a substance which is having sour taste. And the most important thing about that, it gives the H ions in the water. Do you remember this thing that we have discussed about the water also, that how acid behave with water? That it gives the H ions, and such type of substances we call them as the acids. Now if we talk about bases, so bases are opposite of the acid, you can say. That the basis is some chemical substance which is having a bitter taste and a soapy texture, not exactly opposite, but it is different from acid. So that's a, student, whenever you touch the soap, so it always having some slippery kind of texture. Exactly, so that's why we are calling it as the soapy texture. So bases are something, or we can say that the bases are those type of chemical substance which are having the bitter taste and have a soapy texture. Okay, so that's the property, or you can say directly the definition of the bases. Now, student, what happened that some of the places it has been written alkali, alkaline. So people get confused, or not exactly people, but students or children who don't know about this thing, that the bases and the alkaline is the same thing. So bases are also called as the alkaline. So this is the another name for the bases. Okay, so as you can see here that some of the examples of bases they have given. Fine. But now, students, I want to tell you one thing. Just listen it carefully. That in the acid, we have seen that they are giving the H ions. But if I talk about base, that what the base is given in the water. So as we have seen that, okay, base is something or chemical substance which is having bitter taste and the soapy texture. But if I give you the example of base, that is the sodium hydroxide is one of the example. Sodium hydroxide, which is having the formula of NaOH. So students, what happened that the bases in the water, so they give the OH negative ions, or we can say that they give the hydroxyl ions. For example, if I say potassium hydroxide is also an example of base. So they give, it's like KOH, so they give OH negative ion in the water. So that's a, student, acids are giving H ion and bases are giving OH negative ion, and when we mix them together, that's why due to the formation of the H ion and the OH negative ion, when they combine together, so when they combine together, there is the formation of the water. How? That there is the H ion plus OH negative ion, and they combine together and form the water. That means we are getting what form from here? We are getting neutral. That is why we call that as the neutralization reaction. So bases are something which is giving the OH negative ion in the water, and that's why we consider them as the base, and the acid is something which is giving the H ion. Yes, eventually we know this thing that by the taste, that okay, taste is sour or the taste is bitter, so they, that is acid and that is base. But students, what happened that we can't eat everything. Like, will you be able to eat soap? Exactly, no. So how will you come to know that whether the soap is having acid or a base? So that's how, student, we have some test, and even though we know this thing that when the base is there, so it will give the OH ions. Fine, that is the hydroxyl ions. So these are the base, students. Now, if you remember that in the acid part, I have told you one thing, that what are the strong acids and what are the weak acids. So the same thing is here, student. If I ask you what is the strong base and what is the weak base, so students, the base is classified on the basis of their strength, is that is the strong base. Strong base is that type of chemical substance or that type of base which gives more number of OH negative ions. For example, NaOH, KOH. So these are the examples of the strong base. But if we talk about weak base, fine. So weak base is something, student, which is giving less number of OH ions. Okay, and for example, we are having ammonium hydroxide, that is the NH4OH. NH4OH is a weak base which gives the less number of OH ions in the water, whereas the NaOH and the KOH are those bases which gives the more numbers of OH negative ion in the water. So that's a, student, first of all, what are the bases? Bases are some chemical substances which are having bitter taste, but they are also having some soapy texture. Then bases are also called as the alkaline. And if we talk about in the terms of the ion, so bases gives the OH negative ions. And the examples we have already seen, like sodium hydroxide, potassium hydroxide. And that is why, student, when acid is reacting with the base, so there is a formation of the water which is neutral in nature, and that's why there is the occurrence of the neutralization reaction. Fine. I hope you got this point. Then we have seen the classification of base on the basis of their strength, that whether the strong base is there or weak base is there. And even the student, on the basis of the pH scale, we'll see in the next session that how on the basis of the pH we find out that whether it is a strong base or a weak base. Fine. So don't worry about it. Okay, so now we are going to discuss about the properties of bases. That what are the properties of bases? So yes, exactly, bases taste bitter. I hope we don't have to need to like discuss it. For example, bitter gourd. Even though soaps are there which are having bitter taste, feel slippery. Yes, they are having the slippery texture. They can conduct electricity when dissolved in water. As a student, we have seen the acid that it is performing the ions, or we can say that they are forming the ions in the water, so they are able to conduct the electricity. Because, students, what happened that when we are conducting the electricity, we know this thing that in our houses we are using wires. But if we talk about in the case of water, so what happened that in the water, for example, NaOH is there in the water. So this NaOH ion will dissociate into the ions. That is, it is the cation having the positive charge and it is the anion having negative charge. So due to the presence of these ion, students, and when these ions make some movement, so there is the conductance of the electricity. So that is why they are also the conductor of the electricity, because when they dissolve in water, they form the ions. Fine. Now, if I'm giving you some base and you are not able to taste it, whether it is bitter or not. So, what happens, student, if I ask you that test it, whether it is an acid or a base? So, what you can do is you can use the indicator. What type of indicator? That is the litmus indicator. Can be used to detect bases. That's the bases turn red litmus paper to blue. If you remember in the last session, I have told you this thing that the litmus we are getting in two form. One is the red and one is the blue. If you are taking base in red and there is a red litmus paper, so that red litmus paper will convert into the blue, and that's how you come to know that okay, it is the base in nature. And if you are taking blue and you are adding some base to it, so it will remain blue. So that's a, student, on the basis of the indicator, that is the litmus paper. If the basis, you can say that the red litmus paper is there, and that red litmus paper converts to blue, so we can say that the particular substance is having base. Fine. So this is the property, students. Okay, actually, while teaching this pointer, one thing was coming to my mind, but now within a second, it just got slipped from my mind. I'm not getting what I want to tell you. Just give me a minute. Let me think what I was trying to tell you. I think I was talking about something. Yeah. Okay. I got the point. So students, what happened, that as they are giving the ions, so what happened, as I've discussed about the strong bases and the weak bases, that the strong bases gives more OH negative ion and the weak bases give the less OH negative ion. So that's a student, these strong bases are very, you can say that they are also very dangerous in nature, like we can't use them directly, because if the sodium hydroxide is there, the concentrated one, so what will happen, that you can't use it directly, because if even a single drop of the sodium hydroxide falls over your hand or over your shirt or clothes, so what will happen, student, that it can cause some kind of severe burn to you. So that's a student, sodium hydroxide can't be like, you cannot use it as directly if it is very strong in nature, okay, or if it is very concentrated, that means it do not contain any water content in it. So that's a student, strong acid and strong bases are also different indicators, or you can see that they are also giving the different test with the bases and acid, that in the case of the acid, blue litmus turns into the red, but in the case of the bases, red red litmus, not methyl, red litmus turns into the blue. So that's our student, we have seen some of the properties of bases as well. So what we have seen what are the acids. Acids gives H ion and bases give OH ion, OH negative ions. And when these two ions combine, then we get the neutralization reaction, which we'll see in our next session. Because for now, we have to discuss the indicators as well. Okay. Then we have seen that bitter and sour taste, the taste is having difference. Even though conductivity, you can say that this is the common point. This is the similarity between the acid and base. Common point between the acid and base. Exactly. And even though, like, if we have to test whether it is the acid or a base, so we can use our litmus paper. If the red giving blue, so it is base. If the blue giving red, so it is acid. Fine, students? Okay. So now, after discussing all of the properties of bases and what are the bases, I should move towards the indicator. Okay, so now here is the indicator is. So now student, what is the indicator? Like from the word indicator, what you can think about it? Like what are the indicators? So if I say students that when we are traveling, okay, on road, so what happened? We are having traffic lights. So in that traffic light, students, what happened? We are having three different colors, or maybe some of them are also having four colors. But generally, what I have seen that three colors are there, like red, green, yellow. So the red color indicates that what you have to stop. Yellow color indicates that now you can start, like you just get ready to move. Green color indicates now you can move. Exactly. So these are the colors which are indicating that what you have to do is. So same here, student, in the case of the acid and bases, when you have to check that whether it is the acid or a base, what you can do is you can use the indicators so that you can detect whether it is the acid or a base. Because students, in some condition, you can't directly taste them. Like if I talk about mineral acid, if you remember from the last session, mineral acids, they are very dangerous in nature, you can't consume them, not even a single drop. So students, when such type of condition is there, so at that point indicators help us that whether the substance is acidic in nature or basic in nature. Fine. So that's how student indicators gives the different color in the presence of acid and bases, and from that difference in color we come to know that okay, it is the acid or it is a base. So that is called as the indicators. Fine. Okay. Now, we are having two types of indicators, natural indicators and synthetic indicators. Now, what are the natural indicators and what are the synthetic indicators? Fine, students. So, now first of all, we'll discuss the natural indicators. See, natural and synthetic are same. If you are studying fiber to fabric, and in that it came like what are the natural fibers or what are the synthetic fibers, so it will be having the same definition. But it's just that in that chapter we talk about fibers, but here we like we are talking about indicators. So the natural indicators are something that you can say indicators that are obtained from naturally occurring substances. We call them as the natural indicators. That the indicators which we are getting naturally, we call them as the natural indicators. Example, you can see litmus, turmeric, and china rose. So these are the examples of the natural indicator. Because student, turmeric we are getting from nature, China rose is a rose which we are getting from nature, litmus how we are getting it from nature, so we'll see that thing. Okay, don't worry. Now coming to the synthetic indicator. So synthetic indicators are those type of indicator which made in laboratory. That means they are man-made, artificial indicator you can say. They are man-made, so that's why we call them as the synthetic indicator. And the examples, if you want to see for the synthetic indicator, is one of is a methyl orange. Methyl orange is there, and we'll see if we are having other type in your syllabus as well. So these are the type of the indicators, that the indicators which we are getting from nature, directly from nature. We are not doing anything for that, so we call them as the natural indicator. And the synthetic indicators which the people are making in laboratory, with making in laboratories, or like a man-made thing, so we call them as the synthetic one. Now what we have to see, student, that what's the result of the natural indicator and what's the result of the synthetic indicator, if we have to check whether it is the acid or a base. Fine. Okay, so litmus, first of all, we are going to discuss about natural indicators. So first it is the litmus from lichen. Lichens, you can see here that these are the lichen flower, or you can see, and from these lichens we are forming these red and blue litmus paper. Okay, if it is red and it is blue, so that means if there is a base, so that litmus paper will convert to blue, and if there is acid, so this litmus will convert to red. Exactly, students. So the most commonly used natural indicator is litmus. It is extracted from lichens, like we extracted from lichens in different from, one in the acid, that is the red color, and one in the blue color. So that when we dissolve it into any acid or base, so we will be able to find out the color. Generally, it is available as red and blue litmus paper. Okay, so when there is the blue litmus paper and you are adding base into it, so there will be no change, because what the thing, student, that the base will give blue color, and if you are adding the blue color litmus paper into the base, so how you are expecting to be color change? It is not going to change the color, it will remain same. But if you are adding acid, so definitely it is going to show the red color. So students, for the indicators, what you have to remember is that what type of the color change they are showing in the presence of acid and base, so that you can differentiate whether it is an acid or a base. Fine. And that means we have discussed about the litmus now. Okay, now coming to the turmeric. Turmeric, students. Okay, so now I understand why a turmeric stain on my white shirt is turned to red when it is washed with soap. It is because the soap solution is basic in nature. See, how we use the turmeric as an indicator. Like you can take water, and in that you can add 1 or 2 spoon of turmeric, and you can mix it, so you are getting turmeric solution. Fine. Now you can see that in this condition it is yellow, and in this condition it is red. If you observe this statement, so what the statement is saying, that you are wearing one shirt, and on that shirt there is the turmeric stain, and if you washed it with the soap, so what happened? The yellow color, when you are washing it with soap, so the yellow color of turmeric is going to be changed into the red. Okay, that means, students, soap is what? Soap is basic in nature, as we have already seen, because it is bitter in nature and slippery also. And in the soft formation, student, NaOH is used up. Okay, so that's how it is basic in nature. So what we have seen, when we are adding the base to the turmeric, so it is giving the red color. But if we are adding the acid into the turmeric, so it will remain yellow. Fine. As you can see that this is the lemon juice. Lemon juice, you can say. Okay, and this is the soap solution. Okay, so if this is the turmeric water you have taken in the 2 glasses, when you have add the soap solution in the turmeric water, so what you can observe, that it is showing the red color. But when you have add the lemon juice into the turmeric water, so it will remain yellow. That means, student, there is no color change. So in the case of the turmeric, if you are using the turmeric to detect whether it is the acid or a base, so in the case of the base it is showing red color, and if it is the acid it will remain yellow. Because what we know, student, that lemon juice is what? Lemon juice is having the That is it is coming out from the lemon, and lemon is what? It is sour in taste. That means it contains what? It contains acid content. That is why it is not showing any color change. Fine, students. I hope you got this point, that why like soap is giving red with the turmeric, and the acid is giving yellow only. Okay. So that is a turmeric indicator, and it is also again a type of natural indicator, because in turmeric, from where we are getting? From the nature only. Now come to the China rose. Okay, that what's the effect of the China rose? So student, how you can prepare the China rose in the form of the indicator? What you can do, students, like you can take one utensil, okay, and in that you can take water, and now in that you can add China rose. Fine. Now you can boil it. Okay, you are boiling it. So just boil it for some time and then keep it aside, and then you can filter it. From that you are getting the indicator. As you can see here, that this is a China rose indicator liquid. So after boiling it and keeping it out, and when you separate out the China rose from it, and you are getting the liquid, so that's how student like you can see that the color of the China rose will come to the water. So this is the indicator. Now you can see, student, that when the acid is here, and the presence of the China rose, is it gives some kind of yellowish orange color. Yellowish orange color. But if we look at in the case of the base, so it gives some kind of green color, like whether it can give dark green or it can give light green color. Fine. So for example, student, if there is one acid, like if I'm taking again lemon juice I'm taking, or if I'm taking vinegar, so what color will be shown by the China rose? So students, the lemon juice and vinegar both contain acid. So when there is the China rose, so what will happen? That the China rose pinkish color, that pinkish color is going to be changed into the yellowish color. And that's how we come to know that, okay, they contain acid. And when we talk about the base, for example, if I'm taking again soap solution or baking soda, because it is also basic in nature, so it give green color. So that's a student China rose. When we are using China rose as the natural indicator, so in the case of the acid it gives yellowish orange color, or in the case of the base it gives green color. Okay, so till now we have discussed three of the natural indicators. One is the litmus, second is turmeric, and third is China rose. Fine. Now we are going to see some synthetic indicators, that the indicators which which we made in our laboratories. So that's how we are going to see the methyl orange. First of all, it is a type of what? It is a type of the synthetic indicator. Okay. So synthetic indicator, that is the methyl orange, student. So this methyl orange, as you can see here, that this is the methyl orange. So methyl orange, alkali. So just remember, alkali is what? Base, and acid is here. So we can see this thing, that the methyl orange, in the case of the base, it is giving red color, and in the case of, oh sorry, it is not the base, it is the acid. It is giving the yellow color. In the case of the acid, it is giving some red color. Fine. So that's how, student, when there is the acid or a base, so it gives the yellow color or the red color. Now student, for example, there are two test tubes. Okay, two test tubes are there, and both are having some solution. Okay, it is A and it is B. Now I'm asking you that both are the like acid or base, but you have to tell me that in which of the test tube there is the acid or there is the base. So now what you have to do is you can add one drop of methyl orange in both of them. If, like for example, I'm taking A is giving red color and B is giving yellow color. So what you will observe, that B is giving the yellow color, so definitely the B will containing some basic solution. Some basic solution will be there, and the alkali, that is the A, which is giving red color, so definitely it will having some acidic solution. Fine, student. So that's how you can identify the difference, whether it is the acid or a base. Because student, if I take another example like HCl or NaOH, so now we know this thing, that HCl is an acid and NaOH is a base. So methyl orange will give different color. For NaOH it will give yellow, For HCl, it will give red because HCl is acidic and NaOH is base. So that's the difference of the color if we talk about methyl orange. And this methyl orange, student, we can't find out in our houses. We generally find out this methyl orange in laboratories. Like if you are going to some shop and you are asking to the shopkeeper that, uncle, please give me methyl orange, so you will not get it there. Fine, because it is generally found out in the laboratories. So this is the color difference with the help of methyl orange. And this methyl orange, students, generally use in the titration. Now you'll say, ma'am, what is the titration? See, it is a experiment which we do in the chemistry, so that we can detect that whether the acid is present or the base is present. So generally we use these indicators in the titration. For now, it is just enough for you. Okay, now it's the turn of the phenolphthalein. Phenolphthalein, students, is again a synthetic indicator. So in the case of phenolphthalein, student, if you can see, it is acid and it is colorless. And in the case of the alkali, that means base, it is showing pink color. So what we can see, that if we talk about acid and base in the presence of phenolphthalein, so it is acid and it is a base. So for the acid, it will be colorless, and for the base, it will be pink. Fine, students. For example, if I take the example of acid, like sulfuric acid is there and baking soda is there. And now I'm asking you that what would be the color of phenolphthalein in these two cases? So you will say, ma'am, sulfuric acid is acidic in nature. So when you add the phenolphthalein drop into the solution of sulfuric acid, it will remain colorless. And from that, I'll come to know that, okay, it is acid. And in the baking soda, it is a base. So that is why, ma'am, when you are adding the phenolphthalein drops into the baking soda, it gives pink color. Okay, so that's how, student, on the basis of the difference of their color, you will identify whether it is an acid or a base. And phenolphthalein is also used up in the titration process to detect whether the acid or base is there. Fine. So we have seen all of the color differences. Litmus, if it is the red litmus and you are using base, so it converts blue, and the blue litmus converts to red in the presence of acid. If we talk about turmeric, so turmeric gives yellow color with acid, and with base it gives red color. China rose, China rose gives yellowish color with acid and greenish color with base. Methyl orange, methyl orange gives red color with the acid and the yellow color with the base. Phenolphthalein, phenolphthalein gives colorless in the presence of acid and pink in the presence of base. Fine, students. So now you remember all of these indicators color? Good. So now we are having some questions because we have discussed all of the topics of this session. So now what are the question here? Okay, so you have to mark whether it is true or false. Okay, now let's start it. Nitric acid. So it is the name is only having in nitric acid is HNO3. A name is already having acid, so we know this is acid. It turns red litmus to blue. Acid turns red litmus to blue. Is it possible? If there is the red litmus, okay, and in that you are adding HNO3, that is acidic in nature. So what will the result? It will remain red. It will not convert into the blue because red litmus converts into the blue for the condition of base. That means this is the false statement. Exactly. Sodium hydroxide, that is NaOH. Now NaOH is what, student? Base. It turns blue litmus to red. Blue litmus to red. Just think about this. That blue is there, litmus, and NaOH you are adding. So what would be the color? It will remain blue. It will not going to change it. If it is like that, blue turns the litmus red. So what happened? That it is the condition of acid. So again, this statement is false because base can't convert the blue litmus to red. It will remain blue only. Fine. Third statement says sodium hydroxide and hydrochloric acid neutralize each other and form salt and water. So now sodium hydroxide is NaOH, hydrochloric is HCl. So what will happen? H and OH combine together and form H2O plus NaCl. And NaCl is what? It is the sodium chloride. Now, if I ask you what is sodium chloride, so you will say, ma'am, it is the common salt which we use in our houses as well. So definitely student, when acid is reacting with the base, it is forming the salt and water. And we can see here student, it is a base and it is a acid, and yes, they are giving what type of reaction? Neutralization reaction. So that means this statement is true. Fine. Okay, so we are having more true and false. Indicator is a substance which shows different colors in acidic and basic solution. Exactly, they are showing the different color. That's how we are coming to know that whether it is the acid or a base. So exactly, it is the true. Tooth decay is caused by the presence of base. When there is a base, so it is caused by, like, the tooth decay is causing by the presence of base. Exactly. See student, for the tooth decay, what happened? I'll tell you. This is our buccal cavity, okay, where we eat food, like where we chew the food. So what happens student, the region of our mouth is acidic in nature, okay, the region of our mouth is acidic. I'll just write down here that the region is acidic, mouth region. Fine. When you're eating so much of sweets, chocolates, or toffees, so what happens, students? That the sugar which are present in the chocolates and in the toffees, so that sugar convert into the acid. Okay, when you are having it in your mouth, because enzymes are there and they are performing their action, so that sugar converts into the acid. And see, student, due to which what happened, that the region of our mouth will become more acidic in nature. It will become more acidic in nature, and when it is becoming more acidic nature, so it is causing the problem of tooth decay. So now you can see they are saying tooth decay is caused by the presence of base. Exactly, no, it is false. Whether student, by using the base you can get rid of the problem of tooth decay. When you're eating so much of chocolates and toffees, that's why your mother or father advised you to brush your teeth twice a day, because by brushing your teeth, when you use the toothpaste, so that toothpaste is having base, and that base neutralize the acid, and that's how you can get rid of the tooth decay. So the reason behind the tooth decay is the acid, but you get rid of because of the base. So this statement is false here. Fine. So you can see false, false, true, true, false. So let me check my answer. So it is like false, false, true. False, false, true. Okay. True, false. Exactly. So all the answers are correct, because I have, what the thing is, that I have read my chapter very carefully. That's why I'm able to give good marks. Oh, sorry, good answers. And that's why I'm getting 5 out of 5 for that, because I have solved all the questions now and I have given all the correct answer. So that's why I'm getting 5 out of 5. If you're also listening all the points, all the things very carefully, so that's how you're also getting full marks in your exam. Okay, so these things we have discussed today. Now students, what you have to do is that you have to learn all these indicators very carefully, because I know that different indicators are there, different colors are there in each and every condition. So you have to keep each and everything in your mind, but it's not very difficult, it's very easy, you can do it. Okay, so just try to remember it, and then you can have the indicators in your houses, and you can also do the experiments with turmeric, with the soap solution, with lemon juice. Exactly. So that's how you can apply these things in your houses as well. As well, you are not getting methyl orange or phenolphthalein. So don't worry, you are having natural indicators. Use them. Fine. So that's how we have completed the topics which we have to cover today. And now student, what you have to do, like after watching this video, if you are having any question, any doubt is there, you can post your question on the public or private forum of Ask IITians, and you will get your answers from experts, and that's how you are also getting full marks like me. Thank you so much for watching this video, and most important thing, keep learning from Ask IITians. Thank you.